Okay, 1.2, this is what is a function. So we're kind of introducing what a function is. A few more definitions if you hear me use these words. So if I use the word relation, relation just means any pairing between two groups. So you have X's and you have Y's. You have an input and you have an output. So each item in the group must be paired. So each item must be paired. But you can have repeats. So there could be 2 1s as inputs or 2 1s as outputs. So put can repeat. We'll learn here in a minute that there are some functions that cannot repeat. So almost anything is a relation unless you have like one value that is out by itself and it doesn't have a pair. So if there's one sad, lonely X value that doesn't have a Y value, then that would not be a relation. But almost any graph that you see, it's always going to have an X and a Y coordinate. So every single graph that you see will be a relation. Never seen a graph that is not a relation. But if I ask you, is this a function? Then it has to pass the vertical line test. So passes vertical line test. So what I mean by the vertical line test, if you look at a graph and you take your pencil and you scan from left to right, that means that you have to have all unique X values. Like it can't have 2 intersections on the vertical line test. So we're going to get some practice doing that. So if I have a function that looks like this, would this be a function? Like if I took my pencil and I scanned from left to right, does it ever overlap my pencil more than once? No. If I had a graph that looked like this, and I did the vertical line test from left to right, if I'm scanning left to right, is it ever going to intersect my pencil at more than one point? Yes. So I would say that this is not a function, but this is. So it needs to have all unique or all different. If you want to write the word different, that's okay. All unique X values. So basically every single X value is different on the top picture. On the bottom picture, okay, I have an X value at -1 maybe, but then I have 2 separate Y values. So it's -1, 2, and -1, -2. So it intersects twice. So that's why I would say that the second picture is not a function. And then I have what I call, so it's getting more and more specific. Relation is like anything is a relation. Function has to pass the vertical line test. Then if I ask you if it's a one-to-one function, it has to pass vertical and horizontal line test. So this is the most specific one. So if I'm doing a horizontal line test, that means I take my pencil and I make it horizontal and I read it from bottom to top. So that means that it can't intersect left to right either. So with the top picture, would that be one-to-one function? If I did the horizontal line test, is it going to intersect more than once? Yes. So here and here, here and here, it's not one-to-one. And since the second picture is not even a function, it's for sure not one-to-one. So you can't be one-to-one and not be a function. It's like getting more and more specific. So it's for sure not one-to-one because it's not even a function. An example of a one-to-one function would be maybe like a line. Just as any linear is a one-to-one. Because if you go bottom to top, left to right, it's going to have all different x values and all different y values. So I'm going to write that. All unique x and y values. So no repeats. You can't have any repeats. You can't have 2 1s. You can't have 2 2s. No repeats. Sometimes on the SAT or the ACT, they will give you like a real life example to see if you actually can conceptualize what one-to-one function or what a function means. So if we look at these 2 boxes, this would be essentially like our x and our y. Sometimes they refer to them as input output. So you could even write that as well. But let's say that my input or my x values are all the cars in Texas. And then my output is the license plate numbers, that car's license plate number. So I would say that this is a function, yes, because every single car in Texas is different. There are no 2 cars that are exactly, they might be the same model and the same color, but they're not the same VIN number. Like they are all different. So I have all unique x values. Would I say that this is a one-to-one function? Does that mean that every single car has a different license plate number as well? Anyone have the same license plate number as someone else in Texas? No. Right, they wouldn't be able to track you. The police would not be able to hunt you down if you were speeding. So, or you committed a crime or something. So no one has the same license plate number. So then I would also say that this is a one-to-one function because I have all different x values and then I also have all different y values. So it is one-to-one. Just put a check mark next to it. Okay, look at the second one. It says that this is not a function, but can anyone tell me why they think it's not a function? Yeah, what do you think?
Yeah, some people can have the same shoe size as function.
Okay, but shoe size is my output, and then if I'm asking if it's a function, what am I looking for repeats of? The x values. My x value in this example is what? Ages. Can people have the same ages? Yes. So since people can all have the same age, that means that my x values are going to repeat. So it's not a function because I could repeat ages. If I had something like cars in Texas and then shoe size, then that would be a function because my x values are different, but my y values could repeat. So that would mean that it is a function, but it's not one-to-one. So think about function is no x values repeat. One-to-one means no x and no y. So you might even just want to write that to the side because that's a shortcut of how I remember what something is. If we look at numbers, so for part B, I'm going to look at the top one and it says that this is a function. What I usually do when I'm given a set of ordered pairs is I circle all of the x values. So I'm going to look at 1, 2, 4, and 5. 1, 2, 4, and 5. Do any of those repeat? No, they do not repeat. So then that would mean that it is a function. Is it one-to-one? No, why not? There's 2 3s. So I have 3, 4, 3, and 1. These 2 3s repeat. So it is not one-to-one. I look at part B, it's not a function because why? The 4s repeat. So 1, 4, 4, and 5. These 4s repeat. So if you want to write for yourself, like for number 1, it says y is the first one in each group a function and the second not a function. The first ones have unique x values. The second ones do not. So maybe you just want to say the first examples have different x values, different x's. So what I want you to do is I want you to do 2 and 3. You can either make it a numerical example or you could be creative and make it a real world example. So I want you to do 2 and 3 on your whiteboard, and then I will come by and check it. Number 4, is number 4 a function? No, why not? Because of the 5s. So no to a function, which automatically means that it is what? Is not 1-to-1. So no and no. Number 5, is number 5 a function? Yes, because no x values repeat. Is it 1-to-1? No, because of why? Yeah, I've got the 2 zeros. So it is not 1-to-1. Number 6, is it a function? Yes, I have all different x values. Is it 1-to-1? No, because the 2 5s. Okay, number 7, if I'm reading it from left to right, vertical line test. Does it pass? Yes. And then I kind of helped you out with this because the picture's weird. If I'm going from bottom to top, horizontal line test, it never repeats y values. So it's getting bigger and bigger as we go along. It doesn't ever repeat. So it also passes the horizontal line test. So yes, it is 1-to-1. Okay, number 8's a little tricky. If I'm doing the vertical line test, does it pass? Yes or no? No, because where? Yeah, where those 2 points are, it's going to cross both of those. So I would say no, not a function. And if it's not a function, then it is not 1-to-1. Awesome.